All right, so let's get started with the do now. What is the frictional force type and magnitude when an object has 10 newtons of force applied to it and the object remains in equilibrium? You've got 5 minutes. Make sure you start with the free body diagram. How many forces are acting on the object? What should the net force be? What does it mean to be in equilibrium? If you think you've got your answer, is it possible to come up with the coefficient of friction? If you can, see if you can calculate it. All right, you've got 1 more minute. What's going on at the interface? Is there slipping and sliding? What type of force would that be? All right, 30 more seconds. Wrap up your answer. 10 more seconds. All right, awesome. All right, so to answer this question, we want to start off with a free body diagram. So here is our object. And we're told that we're trying to figure out what is the frictional force type and magnitude when there is a 10 Newton force applied to our object. Now, the key is that it tells us that the object is in equilibrium. What can we conclude from the object being in equilibrium? Well, we know that equilibrium means that A equals 0. And the only way A can equal 0 is if F net equals 0. So we know the frictional force is going to point in the direction that would be opposing the motion. And without friction, this box would certainly move to the right. But because there is friction pointed in the opposite direction, the box doesn't move. It must have a magnitude of 10 newtons. How about the type? Well, if we're in equilibrium and our object is at rest, then that means we have static friction. How about that coefficient of static friction? Can we figure it out? I don't think so. We can't figure it out because while the friction right now is equal to 10 newtons, what about if we push with 20 newtons? Would there be enough friction to oppose us? We can't say for sure. We just don't have enough information. So we can't figure it out yet. So today we're going to take a look at some example questions on solving a friction problem. I know it's kind of weird to not have me there, but I think we're going to do great with this different format. So our process for today is I'll read a question to you. I'll give you time to work on it in your groups. The countdown timer will go off, and then we'll go through and solve the question together. So our first question here is, a constant eastward horizontal force of 196.7 newtons is applied to a 20.4 kilogram crate moving towards the east on a level floor. If the frictional force on the crate has a magnitude of 135.5 newtons, what is the magnitude of the crate's acceleration? So you've got 10 minutes. Make sure you get started with your guess table. Fill out your givens and your unknowns. How many forces are acting on the crate? Make sure you draw them all on your free body diagram. What's the net force in the vertical direction? What's the net force in the horizontal direction? Once you know the net force, how can you use that to determine the acceleration? Does your answer seem reasonable? What would happen to the magnitude of the friction if the applied force was increased? And how about the acceleration? Compare what you've got with the table you're sitting next to. All right, 2 more minutes. All right, 1 more minute. Finish up where you're at. All right, so let's take a look at what we've got here. So the first thing I want to do is I want to write down my given information. So the first thing I want to write is that we're told that the applied force is 196.7 newtons. The mass is 20.4 kilograms. And the frictional force is 135.5 newtons. What we're trying to solve for is the acceleration. So I'll do my little free body diagram in the box right here. So if this is my crate, right? I'm pushing to the east, right? So this would be my 196.7 newtons. And my friction would be opposing that motion, right? So my force of friction points to the right, and it is 135.5 newtons. So to solve this question where I'm trying to determine the acceleration, I'm going to need to use Newton's second law. Where Newton's second law says the acceleration is equal to the net force divided by the mass. So now we have to figure out what that net force is. So the net force is going to be equal to that sum of the forces. Okay. Well, I see that they're in opposite directions, so I'm going to need to subtract. So 196.7 newtons minus 135.5 newtons. And when I do that subtraction, I'm going to get 61.2 newtons. Now I can take that 61.2 newtons, plug that in for F net. I can take my 20.4 kilograms And that should give me my acceleration. No algebra needed. I can just do my straight substitution. And so now I will end up with A equals 3 meters per second squared. Awesome. If we increase the applied force, the frictional force won't change, but our acceleration will go up, right? So if I push with more force, my acceleration go up, but my frictional force will stay the same. Why is that? Well, that's right. That's because we're dealing with kinetic friction, and kinetic friction is going to be a constant. Okay. All right, so now what I'm going to have you do, it's a lot of the same, it's the same setup, but now I'd like you to solve for something slightly different. All right, solve for the coefficient of friction. I'll give you 5 minutes for this one. How can you use information you've already figured out to help you? Make sure you use that free body diagram you drew. What should the units be on your coefficient of friction? How are you going to calculate the normal force? Halfway through. Would your coefficient of friction change if we change the applied force? What about if we change the normal force? Thirty more seconds. All right, so let's take a look at what we would need to do here. So I'm going to jump ahead and just start thinking about what would be my free body diagram. Okay, I would have the weight of the box pointed down and the normal force pointed upwards. Okay, and so we're given information about the mass. We're told that the mass is 20.4 kilograms. And we know that G is 9.81 meters per second squared. And so we're trying to figure out the coefficient of, in this case, kinetic friction. So we know there's a relationship between the force of friction, which in our example is 135 newtons, 135.5 newtons equals the coefficient of kinetic friction times the normal force, which I can solve for the coefficient of friction and get that it is the force of friction divided by the normal force. So I plug in 135.5 newtons divided by 200 newtons, which is what I get when I multiply M times G. Right? Remember, N here is going to be equal to M times G because A in the Y direction is 0. So these two forces must be equal to each other. And I plug that into a calculator. I get that the coefficient of kinetic friction is 0.6775. Now, this formula makes it look like that if we change the normal force, that we would end up with a larger or smaller coefficient of friction. But remember, the coefficient of friction just depends on the interface, right? What are the two materials that are touching? So if we try to increase the normal force by increasing the mass of the object or pushing down harder, there would be a corresponding change in the frictional force, right? So both would increase in the same way, leaving their ratio the same in number. The only way to change the coefficient of friction is to change the interface. Or you have the ability to like add a lubricant or oil, graphite, but that's changing the interface. Just by pushing harder, by having more normal force, does not change the coefficient of friction, even though it changes the frictional force. All right, so the last question I have you work on came from a Regents exam a couple of years ago. So the diagram represents a 4 Newton force applied to a 0.200 kilogram copper block sliding to the right on a horizontal steel table. Calculate the magnitude of the force of friction acting on the moving block. So you got 10 minutes. Actually, we'll do 8.5. Again, start with the free body diagram. Where will you get the coefficient of friction? What about the normal force? Where will you get that from? What kind of friction is this? All right, let's take 2 more minutes. If you've got your answer, is the block speeding up or slowing down? One more minute. Thirty seconds. All right. So the key to this question is actually recognizing that we can figure out the coefficient of friction based off of the two materials that are given. So we're told that we have a copper on steel interface, and we're told that V is not equal to 0. That means our coefficient of friction needs to be a kinetic coefficient of friction. And looking at the chart, I see that copper on steel has a kinetic value of 0.36. From there, we also need to use that the mass of the object is 0.2 kilograms. Now, what we're trying to figure out is the force of friction. And our equation is that the force of friction equals, of kinetic friction equals the coefficient of kinetic friction times the normal force. We'll get the normal force the same way we have been, since the normal force and the weight of the object are in opposite directions. So they're equal in magnitude. So I get out my calculator and I need to do 9.81 meters per second squared times 0.2 to get that the normal force is 1.962 newtons that I multiplied by the coefficient of friction, 0.36, for a frictional force equal to 0.71 newtons. Since this amount of friction, right, if I think about my free body diagram, I'm pulling it to the right with 4 newtons, and friction is opposing it with 0.71 newtons, right? My net force is going to be 3.29 newtons to the right. And if I wanted to, I could figure out what that acceleration is using Newton's second law. Well, thanks for watching. You have all the tools that you need to complete the homework assignment due Friday night. If you have any time remaining, feel free to do that. Thanks for watching.